mathematicians, we are looking at part 2 of our Unit 8 and, of course, assessment. And we're going to pick up with question 7 here. It says, again, select all the expressions that have a value of 1 million. So we're really looking for all of these that are equivalent or other ways to say the same as the word form here, 1 million. So let's start with just, if you already did this problem, which are the ones that you should have selected? We should pick B, we should pick D, we should pick E, we should pick G. So let's start with why A, C, and F are not options that you should have selected. Well, first of all, we have seen so many patterns in our powers of 10. And one of those patterns that we've seen is that the exponent always matches the number of zeros that the value has. Well, this value would only be 1,000, which certainly is smaller than 1,000,000. So we should not select A. Now, should we select C? Let's use similar thinking. It should be a 1 with how many zeros? A 1 with 7 zeros. So let's count those out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, comma, 1, 2, 3, comma. Uh-oh, this one is actually too big because it should be, as we're going to see, it should be 10 to the power of 6 because we want it to have 6 zeros to be 1,000,000. So this one is not one you're going to select for C. Let's go to F. If I have 100 times 100, really I can take a 1 and put my zeros that are in this factor, my zeros that are in this factor, I can put those together. And certainly, again, we see 10,000 is not the same as 1,000,000. We should not select F. All right, now let's talk about the ones that we should pick. We should pick 10 to the power of 6 because that's going to be a 1 with how many zeros? Well, exactly what the exponent is. So we're going to have 1, 2, 3. 1, 2, 3. That gives us 6 zeros. And certainly this is equal to 1,000,000. So we should select B. Why should we select D? Well, we have it in value form here. We have it in word form here. We should select D, right? Those are equal. Now let's take a look at actually at E. How many tens are being multiplied together? Let's count them. 1, 2, 3, 4, 5, 6. That represents the 6 zeros that are in 1,000,000. So yes, this is equal to this. We should select E. And lastly, if we have G, we have 100 times 100 times 100. Again, we can think about that as a 1 with the 2 zeros here, the 2 zeros here, the 2 zeros here. That's a total of 6 zeros. 1, 2, 3, 4, 5, 6. Yes, that is equal to 1,000,000, and we should select that. So that is the why behind those 4 that are circled, and of course the no behind the ones that are X. Let's take a look at number 8 now. We are looking at some dividing. Find the value of each quotient and explain or show your reasoning. Let's take a look at A first. And let's go ahead. We have learned several strategies for dividing. Let's go ahead here and do let's do partial quotients. So I'm going to put my 21 outside. I am going to go ahead and I'm going to put my 1,512 right inside the division box because this is my dividend and this certainly is my divisor. Okay. Now, when I take a look at this number 8, we are going to ask ourselves first, okay, what would be a reasonable amount of groups of 21 that we could get from this? Well, I can't take 100. Let me show you why not. My students really like the ones who start with the strategy. They love it when they can take a 10 or 100 first. Do you see how that really does not work, right? I don't have 2,100. So I cannot take 100 to start us off, But I certainly could take a group of 50, couldn't I? Because we know that 21 times 5 is going to be, of course, 105, right? Because we know 20 times 5 is 100. There's going to be one more group of 5. So if 21 times 5 is 105, I know that 21 times 50 is going to add a 0 down here. And that is a great amount to start with taking because look, that's going to use a good portion of that without going over. So here we have 2 minus 0 is 2. 1 minus 5 we cannot do. So we will borrow here and we will give it here. We have 11 minus 5 is 6. 4 minus 0 is 4. And 1 minus 1 is nothing. So we have 462 left. Well, let's think about this relationship. We saw here that 21 times 5 was 105, right? So, could I take 21 times 4 in this case? Well, I know that 21 times 4 is going to be 84. That's good. Could I put a 0 to it? No. But notice, boys and girls, how close I am. So when you are, how close I am to a half is what I'm thinking. Notice, boys and girls, when you do this strategy, and this is my point, what I want you to think about is kind of over to the side, just having some brainstorm, right? 21 times 40 was too much. But if I had 21 times 2, right, that would be 42. So, therefore, I know that taking 20 groups of it would actually be 420. So notice here, boys and girls, now I know I could take 20 groups. 20 times 21 is going to be 420, which is going to give me a difference of 42, which I know 21 goes into 42 exactly 2 times. 2 times 21 is going to be 42, and there's none left over. Now, if when you're doing partial quotients, you record your partial quotients over to the side, like is our practice, you have your answer right here. And you simply think 50 plus 20 plus 2 is 72. We like to record it over to the top like that. My students, however, we really like to come and write it to the side, but certainly within IN, there's a lot of recording it on top, which is great as well. But in any case, we are going to get to this, which is 72. Okay, so again, let's rewrite this. We have 1,512 divided by 21 is going to equal 72, and I'm going to circle it. Now, I'm going to go ahead and show one other solution because this solution certainly is a great strategy as well. I did not really see it in my students when we did our problem solving. So certainly this is something that you could think about as well. And it is in the key itself. So I'm going to show it here, even though, like I said, this was not something that my students did. Now, notice here, we're starting with the same thing, right? We have 1,512, and we're dividing it by 21. We know it's going to equal 72, and they certainly arrived to it here. Now, notice what they did was the 50 times 21 is 1,050, right? Which certainly is what we got to here. Then they thought, okay, well, 20 times 21 is 420, which we got to here, right? Then 2 times 21 is 42, which we got to here. And then they just added these up at the bottom to have 1,512. They repeated the group because it was always being divided into a group of 21. And then they looked at 50 and 20 and 2 to give them 72. So interestingly, in the key, they have it written out like this, right? But certainly as we study this and as we study this, we see that really what we're looking at is still the same idea of the partial quotients, right? We're portioning out all of this, the 1,512, into portions of 21. And we certainly see it almost like a running record in the key that they created. Okay, let's go ahead now and let's take a look at B. Let's take a look at B. We have 7,776, and we're dividing it by 36. Yes, when you do this, boys and girls, let's go ahead and as we were doing, especially in the part one video, let's actually start with what our overall answer is, because I do want you just to check and see, did you do this correctly? Well, you did it correctly on your own if you got to 216. Now, if you did not get to that 216, especially, I want you to pay special attention as we talk through it now. And certainly, let's make sure that we correct it on paper, but also correct it in our brain so that we understand exactly how we're going to portion out this dividend by this divisor, the 36, to get to our answer, our quotient of 216. Well, how many groups of 36 can we start with taking from 7,776? I think I told you in my students really love when they can take a group of 100 first. Well, if I were taking a group of 100, I would do 36 with two zeros. Now, you could certainly start with that and then take another group of that 3,600 to get to the 200, or you could do it right now in one fell swoop, right? Because if I have 36 and I double it, that's going to be 72. And then again, I'm going to have these two zeros. Now, when I subtract that, I'm going to get a difference of 576, right? Now, when I get my difference of 576, I'm going to ask myself again, what would be a good portion? How many groups of 36 can I get from this? Well, let's start with just taking a group of 10 here. When I take a group of 10, I'm going to have 360. And when I subtract this, I'm going to get 216. Okay. Now, if I have 36 and I want to put that into, if I want to get to 36 from 216, how many groups can I get? Once again, guys, just like we kind of had our brainstorm over here, we can have a brainstorm over here. We can literally guess and check. And that is not a sign of weakness. It's a sign of strength. That's what mathematicians do. We try out our numbers. We compare. We want to get as close to 216 without going over it as we can. So let's start with 6, right? If I have 36 times 6, I'm doing 6 times 6 first. That is 36. And here's my 6 carrying my 3. 6 times 3 is 18 plus 3, 19, 20, 21. We have exactly that number that we need, right? So we're going to take 6 groups of 36, and that is going to use up all of our 216. There is no remainder, and my answer is right here. Now, once again, sometimes students will like to record it in the top. We like to record it right beside because then it's like right here. Oh, yeah, that was my 200. That was my 10. That was my 6. But it doesn't matter, mathematicians. We're all getting to the same answer of 216 for 8B. Now, let's take a look at number 9. In number 9, we are playing with this value and the different operations. So we're really thinking about our decimal operations, and we're actually starting with addition. Now, I love in IM how they say this, use the hundredth grids if they are helpful, and they are helpful. That's how we've actually started our problem solving, is thinking about that, right? However, they're not always available. And so my students also practice with just sketching the base 10 blocks as well. We like to use a square to represent one whole, which certainly I could write like that as well. This represents a tenth and this represents a hundredth, right? Now, if we are thinking about these, remember it's like having this and then adding two hundredths. Now, I could certainly draw it like this as well. Let's draw this out to show how we could do it kind of with our sketch based in blocks as well. Here are my two holes. Here are my 4/10ths. And now I'm going to add my 200ths. So here I literally am seeing my place values. I have my 2/1s. I have my 4/10ths, and I have my 2/100ths. That's what I get when I combine 2 and 4 tenths plus 2 hundredths. This is my answer right here. We can sketch it with error base 10 blocks, but again, it's also a good practice to think about drawing your own because it's not always an illustrative math question where they are available if you need them. And also, maybe you use them on another problem and you want to just sketch them out. Okay, let's take a look at B now. We're starting with the same thing. We're starting with 2 wholes. We're starting with 4 tenths. Now, here we are subtracting, so we're actually going to lose 2 what? We're going to lose 2 hundredths. Now, I don't see hundredths to cross off, but remember, boys and girls, we can cash this out. So we are going to cash out this tenth, and we're just going to go ahead and exchange it for its value in hundredths, which is going to be 10 hundredths. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That's like exchanging a dime for 10 pennies. They mean the same thing. Now I actually can lose 200 because this group right here of 200 I'm going to lose. So once again, I can see my place values. I have 2 in my ones place. I have now 3 here in my tens place because remember that fourth tenth I had to cash out for hundredths. And now how many hundredths do I have? I no longer have 10, I have 8. So this is what we have in B, where we have subtracted 200. Now, boys and girls, let's look at multiplying. If I have 2 and 4 tenths, and I want to multiply that by 2 tenths, this is what we're thinking about. And this is what we're thinking about in this problem, okay? Now, the first thing that we could do is we could think about here, let's go ahead and let's think about this. We have 2 wholes, 4 tenths, and we're going to multiply it into 2/10 portions. There are multiple ways that we have thought about this. One way, and certainly we've done this so much this week and in the previous weeks in our illustrative math spiral review, one way that we thought this apart from the base 10 blocks is we thought about turning this into a multiplication problem like this. Certainly, when we've done this, what we first started with thinking about is the fact that we can multiply 24 times 2 as if they're whole numbers. But then we remember that we really had one decimal place value here, and we had another decimal place value here. That gave us a total of 2 decimal place values. And really, that's like after we know the answer to this, then multiplying by 100, right? To remember that we're really thinking about those 100 pieces. Now, if we follow this problem solving, if we can think about turning it into this expression, that's where we can kind of use this procedure. We need to think about the why behind it, but certainly if we understand this idea of first, just considering 24 times 2, which of course is 48, then we go and think, well, there's one decimal place value here and another decimal place value here. So that's like going in 2 decimal place values, which is going to be 4,800. So my answer to this question is 4,800. Okay. Now, boys and girls, and remember, guys, the reason that, let's talk about this too. The reason that this is smaller than what we're starting with is remember, we are not actually taking all of 2 and 4 tenths. Multiplication is really like scaling. If we kept this balance, it would be 2 and 4 tenths times 1. 2 and 4 tenths times 1 would equal 2 and 4 tenths. But we're not taking all of 2 and 4 tenths. We are only taking 2 tenths of it. So, for example, here, take a look. In this, we have shown 2 and 4 tenths. But if I multiply, let's see here, 2 and 4 tenths by simply 2/10 because that is my other factor. This is where my answer would lie. My answer would lie right here, right? I could certainly add up how many hundredths there are. There's going to be 20 hundredths here. There's going to be 20 hundredths here. And then we would have 40 hundredths between these two, 41, 42, 43, 44, 45, 46, 47, 48. That's where we get to our 48 hundredths as well. So we certainly could model it. I do want to show you how you can use the hundredths grids to get to that answer and how we've done that within our program. But at this point, we also can use that efficient strategy as well, especially if we can name it and claim it with an expression. Okay? All right, let's take a look at D. Our last decimal operation is here. We are thinking about 2 and 4/10, and we are dividing it up into portions of 2/10. So really, this is like asking how many 2/10 portions can we get from 2 and 4/10, right? That's the way that we can think about this. So once again, kind of like this, we're going to show it in the procedure in a minute, but I'm also going to show you how you can show it with the grid. So the first thing that I'm going to do is I'm going to erase this because no longer am I modeling multiplying. Now we're modeling dividing, and these certainly have different meanings. Now I can keep this because yes, sure, we're still thinking about the 2 and 4/10, but now this is our dividend. So all of this is our dividend, and now what my job actually is to figure out how many 2/10 portions I can get from this. Well, take a look. Isn't this a group of 2/10 right there? And isn't this a group of 2/10 right there? So I already have 2 portions here. Now I know I have 10/10 here. If I break them into 2/10 portions, there's going to be 5. I could literally write a 5 here and write a 5 here. But for the sake of continuing this, in case you're not seeing it, let me show them as well, right? Okay, so here, boys and girls, look, we have 5 portions of 2/10 in these 10/10 of this whole. We would have the same right here. We would have a 10th, or excuse me, 2/10 and 2/10. We would have 2/10 and 2/10 and 2/10. So how many green circles do we have? Let's count them together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many portions of 2/10 can we get from 2 and 4/10? We can get exactly 12. That is where we get it with the actual model. So if you're using the hundredths grid, this is the way you would show it, right? We have our groups of 2/10. Now, again, at this point in fifth grade math, we've done those models so much, we can also use a procedure kind of like what we saw here with multiplying. Let's talk about how that looks with dividing, right? Well, this is my dividend all day long. Always the first number is what goes inside our division box. This is the dividend. This is the divisor right here. The zero is optional. So I'm going to leave it off, but certainly you could write it. Nothing wrong with either. Remember what we found to be true as we practice this and broke this apart? If I, in essence, multiply this by 10 and turn this into whole number 2, I've moved the decimal one time to the right. This just makes division a little bit easier by thinking about powers of 10. Now, whatever I do to the divisor to turn it into a whole number, because this is my objective, I do to the dividend. So my objective is not to turn this into a whole number, but that's what happened because I mirrored what I did here. Really, it's like I multiplied this by 10, so I had to multiply this by 10 as well. And now I am no longer looking at 2/10, but I'm looking at 2. Well, how many times can 2 go into 24? Of course, it goes in 12 times. We know this fact to be true. Wherever your decimal stops in your dividend, you rocket it straight up into your quotient. And yes, we have our answer of 12. Now, how does that work? It works because really we're thinking about powers of 10. So the same thing is true here, right? Just like we're really thinking about whole numbers and then remembering that we're actually looking at a decimal value, we've done the same thing here, right? Because this has the same answer of 12 as it does in its whole number counterpart. Okay, this is going to wrap up our part 2 video for today. I'm trying to break them into parts, boys and girls, and make sure that you have recorded those answers up to number 9.